Hello and welcome back to the lab. Today on the bench, I've gotten a couple of questions. This is my frequency counter. We have an upgrade that we're going to install in the frequency counter. And I also have some questions about my 10 megahertz reference, which does not exist in the lab at the moment. I've been working on a 10, actually I take that back. I've had a 10 megahertz reference plugged into this frequency counter for a while. This is Leo Bodnar's. I use the Leo Bodnar frequency counter that I've had for quite some time, and it has worked very well, especially being underground in the lab. But I was looking, since I got the spectrum analyzers and a signal generator that can also take a 10 megahertz reference, I wanted to get something that put out sine waves as opposed to square. The only drawback I've had was with the Leo is it only puts out square waves. So I wanted to feed the spec ans sine and get them good to go. But I wanted to get everything going. So as part of this video, I'm going to talk about the 10 megahertz reference, what I have planned. I will let you guys know if I'm successful in the end. I talked to everybody over on Patreon, and we all kind of agree that one of the things that's really important for me in this channel is the transfer of knowledge, both troubleshooting and repair, as well as other topics. So moving forward, anything that gets recorded on the bench will get posted to YouTube. So if it's successful, if it fails, if it goes well, if it doesn't go well, you guys will see everything that's recorded in the lab. I think it's valuable, even if something goes poorly, because somebody will learn something from it. If nothing else, you guys will learn what not to do. Anything that the record button gets hit on, if it turns out good or if it turns out bad, we'll post it. So, starting with this is my frequency counter. The only bad thing about it is the display's kind of dim. I will fix the display in this at some point. I looked, the displays in these are like $200. Just the display. I paid less than that for the frequency counter. So this is actually option 3. This is a clone board. This isn't the actual HP option, but I think Shariard over on the Signal Path did one of these, and he did a analysis of the clone boards with better gear than I've got, and they ended up being okay. So all this is really is a prescaler board. It's a fixed divide by for the frequency counter. So it takes the incoming signal up to 3 gigahertz, does a fixed divide to where the frequency counter can count it, and then the frequency counter just does a bit of multiplication and shows you the results. This particular panel mount is B&C. The reason I went with B&C is because even with the fixed divide, this only goes up to 3 gigahertz. So B&C is plenty fast enough for 3 gig. We don't need to go into the world of N or anything crazy like that. If a lot of your gear is N connectors and you typically work in N connectors, I have seen these prescaler boards that ship with an N connector. So you can go N directly on the front of this. So let me get the frequency counter open. The rubber bumpers pull off, and then there's 2 screws in the back, and it should slide out in the front. And then we'll work on getting this installed. Now I've done it. I just broke the calibration. At least on my example, they are Torx. Oh well. Looks like we can't trust the cal anymore. Now, I knew this when I bought it, but I had actually forgotten about it. This actually has the high stability oven in it. You guys can see the 010. The HS oven, not the U8, not the ultra high stability oven. But that will be okay, because very soon it will be on GPS and it won't be a issue. Is there more on the bottom? There's one more on the bottom. There we go. Oh my. Okay, well, that is dusty. Yeah. So we're going to clean that. Oh, fan turns okay. Here's the crystal oven right here. Mod board's going to go here, 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 and here. And it sits on this panel like so. So very simple to install. You have to knock out the front. And then there is this is the clip for the option 3 board right there. So I don't use canned air at all because I don't think it has enough pressure. So let me get this upstairs and hit it with the pressure washer. Or not pressure washer, compressed air. Not pressure washer, no water. And then we'll get this all squared away, get it all cleaned up. Haven't been in this yet since I bought it. It is, it's dirty. So, very cool. All right, well, I have to go up to the garage for that, so I will get this all blown out, and then I will be back. Okay, since I had everything taken apart, power supply was out. To get the power supply out of this unit, you take 2 screws off the back panel and the 1 main screw on the front, and then the entire power supply comes out as a module, big red cords underneath. I was hearing some hissing noises from the fan bearing when it was on and I was behind it, so given that I had everything apart and we were just servicing up the unit, I figured I would take the time to clean the power supply and service the fan bearing to give it time. No, that cap's fine. Okay, so everything looks okay with the power supply for right now. No problems with it. Caps look healthy. And I think they're, let's see, what are these? Nishikons. So they are fine. At least for the time being. So, I'll get all this reassembled and then we'll get our display board in. Here's where the bolts are. There's 2 bolts in the back, 1 bolt right here, and then the whole power supply comes out as a module. Here's a big crystal. The power connector to the board is right there in the bottom. Okay, and I have the board in. It's bolted to the side of the frame, and I'm about ready to make the connections. So to make the connections to the counter, all you do, 1, get this fish paper out of the way, 2, and done. That's it. That option 3 is installed. The only other part is putting the BNC through the front panel. For lining up BNCs, I had to build something a lot with a BNC for a project, and I found this tool. I'm pretty sure I got this off of Amazon, but this is a BNC alignment tool for when you're dealing with panels. It just fits over that, and then you can hold the BNC while you crank it down on the back without destroying the connector. So, incredibly useful tool if you work with BNC a lot. Let's put the unit back together. Tuck the fish paper in. Chop my finger off, which would be par for the course. No operator serviceable parts inside. Refer servicing to trained personnel. Nah. All right, let's see how it sounds. Oh, the fan's nice and quiet now. And that's one of the reasons why it's so dusty. The fan does run when the unit's off. So that's good to know. So it's not completely powered down. See if it sees channel 3. 1, 2, 3. There it is. So the upgrade was a success. Aside from the dim display, this one's good to go. The board was an eBay purchase. I think it ran about $69, $70 US. So nothing terrible. Okay, this is the GPS module that I'm testing as my 10 megahertz reference for the lab. I've been having some trouble with it over the last couple of days. But I think I'm finally coming to the end of the trouble, and I can let everyone know some findings. I'm going to measure this just to make sure So this is a GPSDO Samsung GPS module. Of course, it comes from a very popular auction site. This one specifically has a Samsung OCXO in it, which is relatively accurate on its own. One of the reasons I liked it is it does 1 PPS. I've kicked around the idea of getting a rubidium standard, but so I didn't have to tweak the rubidium every couple of days. I wanted to get something that could lock to 1 PPS to stabilize the rubidium. I was looking at a Stanford Research module. My ultimate goal was a ultra stable, ultra low phase noise, 10 megahertz reference. And as I fell deeper down that rabbit hole, the ultra low phase noise problem ended up getting in some weird ways. Let's assume you want to sync two pieces of gear with the same phase to a 10 megahertz signal. The two coax cables that you use for that system have to be length matched. So if I put this into a display amplifier, I'd have to make sure the display amplifier was phased correctly. I'd have to make sure all the cables were length matched, because then the cables would act like a delay line, throw things out of phase. It's a lot harder than I want to get into right now in the lab. I may need to get there at some point, but not now. But I did want a 10 megahertz sinusoid out to feed the instruments. The Leo does 10 megahertz square, which is fine for the frequency counter. I've been running that for a year now. But with the spectrum analyzers, I wanted to get 10 megahertz sinusoid. So I looked at this one, and this also gave me the 1 PPS for when I get if and when I get a rubidium standard. You'll notice a little bit of black tape on here. This is the 1 pulse per second LED. The reason for the black tape is this is a red LED, and it is obnoxiously bright. And it was pointed at me while I was doing the testing. So I just blacked it out. It's just stupid bright. DC 9 volts to 24 volts in, which is good. The module, I'm actually really pleased with the build construction of the module. Real nice module, no complaints. Comes with an antenna. The cord could be longer on the antenna. I'm kind of in the middle of an underground bunker in the lab, so the antenna didn't get me very far, which is why I'm having a problem with this module. It doesn't want to lock. I had it locked yesterday. It locked for a little bit, and then it unlocked, and I'm getting signal problems. So I will address that here in a minute. The one thing I do not like about this is this. There's the back for those who are curious. This is a 12 volt switching power supply. It is a 12 volt 4 amp switching power supply, which is kind of crazy. But here's what I don't like about it. The entire power supply, cords and all, is 6.2 ounces. It is cartoonishly light. So I will be doing some testing with this power supply, but long term, I don't want to leave this running. Also, in my jurisdiction, it is not UI listed. So technically, I'm not supposed to plug it in the US. Just a thing. I will be getting a better quality 12-volt power supply, even if I have to build one for the GPSDO. That brings me to this piece of the apparatus. This is a distribution amplifier. It is a video distribution amplifier, so it's a 75 ohm system. It's a 75 ohm system with 50 ohm BNC jacks on the back of it, so not sure about that. The way this is wired is I have 6 outs, and these are pass-through inputs. So if I wanted to stack these, I could have the signal come in off of this BNC cable, come out and go to another one. Now, again, that's good for a 10 megahertz reference. It just throws phasing out the window, so if phasing is important, you can't set it up this way. The way I've got it set up right now is I've got frequency counter and spectrum analyzer. I want to get the other 2 spec ANs on the 10 megahertz reference. The main problem with this is I put this on the scope. It amplifies very well. It amplifies too well. So I was getting 3 volt with the gain turned completely down. I'm getting 3 volts peak to peak out of this thing. So lots of gain for the system. That causes me a problem with the spectrum analyzer and the signal generator. The signal generator actually wants between 0.2 and 0.6 volts peak to peak. The spectrum analyzer wants less than that. To solve the spectrum analyzer problem, I just put a 50 ohm load in there, and it dropped it down into a safe realm for the spectrum analyzer. I need some attenuators for the signal generator first. It also surprised me that the HP 8657A needed such a small 10 megahertz. So it said 0.2 to 0.6, which is nothing. Yeah, so this was sent in by a viewer, so thank you. Definitely using it in the lab. I actually need to tone it down a little bit. The other thing that the GPSDO was sent with that was very helpful when it came was there was a whole bunch of BNC to SMA and some other stuff that made it really useful to hook up. So definitely makes that worthwhile. So to get better satellite signal, because that's what, given that it locked yesterday and it's not locking today, that's what my problems are, is I got this. This is a nautical GPS antenna heading out. This is one of the connectors that they sent, which is actually going to be very useful tomorrow. It's a BNC female to antenna. So this goes on like so. Gives you a BNC on the back. This is going to go outside. This is weatherproof. It's a 28 dB gain antenna, so it'll take the 5 volts that this actually outputs on the antenna jack, sends it out to the antenna. I'm going to measure that I still am getting the 5 volts on the antenna jack, that nothing happened to it. And then so with 28 dB of gain, plus being out of the bunker and above ground and outside, we should have plenty of signal coming in that we can then distribute to the various bits of equipment that need it. So that's my plan. My main problem is I need some BNC to F connectors. Those will be here tomorrow. So when those get here, I will work on setting the antenna up and at least doing a temporary, see if I can get it to lock. If I can get it to lock, I will show you guys how to verify that it is locking with a known signal source. If you don't have a frequency counter, you can actually do that with an oscilloscope. That's pretty cool. You can essentially know how far your frequency's off, down into the millihertz. You can tell, given how long it takes the wave to creep across the screen, you can tell what your deviation is. I'll also do some statistics on this, comparing it with the Bodnar. Now, the Leo Bodnar pulsar, it has never had a problem locking down here in the lab. It's run flawlessly since the day I bought it. Absolutely love the thing. I just want to feed signs into the spectrum analyzers. But I will use it as a comparison reference for this guy. And we'll see if we can't get the frequencies to lock. Because in theory, with them both being locked to GPS, we should be pretty close. There shouldn't be much deviation to the frequency. Lady Heather, I'm using that software to monitor the GPS. It's kind of a quirky software. There's some gotchas that I ran into. It wouldn't start talking initially, couldn't find the module, things like this. I was told this was a U-Blocks module. It's not. It's a UCCN module, but it does have a Samsung OCXO on it, so I'm not too upset about that. But yeah, there was just some funkiness getting Lady Heather to talk to it. If I'm going to run this with any stretch of the imagination, I'm going to get a different power brick. I don't want to leave this plugged in the lab when no one's here, no one's home, and leave this running. I don't trust this power supply. It's too light, especially at 4 amps. I think this thing would melt. Yeah, that's where we're at. I just need to wait on the connectors. Let me plug this in and see if I'm getting 5 volts out of the antenna port, just to make sure that nothing happened to that and it didn't fail, because it locked yesterday and it doesn't want to lock today, which is odd. Oh, hey, I'll plug it in and I'll take this off so you guys can see the obnoxiously bright red light. Oh, and the power supply has a blue LED on it too. All of the LED color problems, at least for my eyes. There's that red LED. It is just ridiculous. That's why I have the green, the yellow one and the green one aren't bad. They're nice and dim, no problem. But that red one is just ridiculous. Okay, we're going to measure the voltage here real quick. You do not want to short these. We are getting our 5.1, so the amplifier for the antenna is still working. But that also is when you're working on setting up the cabling and stuff for these, you do not want to short this out. There's actually power applied here for active antennas. So just be aware. Okay, I've had both GPSDOs online all night, so they were all well warmed up and everything. I'm doing a little bit of statistical analysis on the frequency counter right now. I'm running a standard deviation test, 200 measurements with a 100-second gate time. So if we do stats, it's still collecting data for standard deviation. Let's see, but what I want to see is stats. We want to show measurement. In 100 seconds, this will come up. So it's taking readings for 100 seconds, and it's going to do that 200 times before it shows me the stats. If my math is right, it's going to take about 5.5 hours to run this measurement, but I'll show you what the reading is here in a second while we're talking. It should pop up any second now. The other way I'm going to show you guys the stability between the two oscillators is I'm going to move over to the scope, and I'm triggering off of the Leo Bodnar pulsar, and I'm watching the Samsung module, and they're staying very closely relative locked together. So it's both modules are running very, very well. It should pop up a measurement any second now. Well, it's got to go 100 seconds. And there we go. So it's quite a few zeros. Not all zeros, but it's 2 free running oscillators. So they're at least locking to GPS. But 10, here would be 1K, here would be 1 hertz, here would be 1 millihertz, 100 microhertz. I can handle that. let me move you guys down to the scope, and we'll take a look at that. Okay, here's the scope. I'm feeding the scope with the Leo Bodnar on channel 1, so the yellow, which is also the trigger, and I'm feeding the the Samsung module into channel 2, which is the blue, and I'm triggering off of channel 1. So I'm using my zero crossing as the falling edge. So if the frequencies were off, these would be moving with respect to each other, but they are incredibly stable. This is actually 10 nanoseconds per division. That's 5 nanoseconds per division. That's the fastest the scope goes. You can see some movement here. Actually, let's move the horizontal. So our trigger point is right here. So our trigger point is right here. So we'll use the same point on the blue, and the scope is running. It's not paused or anything like that because it says triggered. But as you can see, the blue slowly moving back and forth just a little bit, but that's how close the oscillators are synced. So I'm happy with that. We're actually pushing the frequency counter to its absolute limits. I also did get it working with Lady Heather. So it's the software's up and running. Everything's locked in. My high score was 13 satellites in view. I think currently there's 12. And I have a pretty decent coverage map being out and about. Now, I did need the external antenna. I tried running this inside for a few days, and the receiver wasn't sensitive enough with the antenna that shipped in, so I had an additional, I think the GPS antenna that I bought, it's rated for boats. It's to be around water, so it's all weather. It's a 28 dB gain antenna. It's plenty fine to be outside. I don't have it up high. It's actually sitting at ground level. Elevation of that antenna actually doesn't matter because it's receiving signals from the top. So just the important part for the GPS antenna is clear view of the sky. So we have it on the ground up close to the lab. So you don't even need a tower to put one up. Now the Leo Bodnar pulsar, it's a fantastic unit. I've had its antenna down in the lab for quite some time, and I did not need an exterior antenna with that one, so it worked. But I switched to get sine wave into the spectrum analyzers and the signal generators. My goal now is now that we have this and I'm doing the final testings on these, is anything that can take an external reference, 10 megahertz reference, I'm going to use. So all of the spectrum analyzers, the frequency counters, everything that I get in the lab that I can run on 10 megahertz, I'm going to distribute that to every unit in the lab. I do hope at some point I actually get some scopes that can have 10 megahertz reference to help their base clocks. At this point, I don't have any of the old and reliable tech stuff. Doesn't have it. You start seeing it on some of the Rigol stuff in the middle 4 figures. So the $3,000, $4,000, $5,000 scopes. And pretty much anything over that price point is going to have a 10 megahertz reference in it. So now my reference isn't phased. So if I need phase measurements between 2 units, it is not taking into account phasing, because now I have to get into I'd have to get into match length cables, and that's a whole nother rabbit hole. But very good. So I'm going to let this testing run. I'm just got the scope on, monitoring the frequency counter and everything like that. So I'm going to let everything go. And when the statistics come up, I will bring you guys back so you can see. The one that I'm really interested in is the standard deviation over the 200 measurements. So, but that measurement's going to take about 2 hours, or 5 hours, 5.5 hours. So, but that's where we're at. So I'll see you guys in a little bit. I'll have to wait. You won't. One other thing that I got curious about was the power supply that came with the unit. So this is supposed to be a 12 volt 4 amp power supply. Not really sure I'd put 4 amps through those cables, but and I'm not even sure where this thing came from. So line cord's supposed to come in here, up here with the isolation slot. It falls across some of the components on the bottom, things like that. This is a switching power supply. Here's the isolation point. I am much more confident in my decision to not use that power supply. This is why it's 6 ounces. There's nothing in there. Being that it is a universal volt input, 9 to 36, I just got some 5 amp power or 12 volt 5 amp power supplies that I had laying around that the pin fit. It's center pin positive, so it's the standard barrel jacks on pretty much everything. But yeah, that's where we're at. Okay, some measurements out of the 2 GPSDOs, which have been going at it for a while. Actually, about 6 hours. 465.6 microhertz standard deviation. I will take that. So some other statistics that we have is the mean. The max was 2 millihertz off, so 2.1 millihertz high. The min was 400 microhertz low. And standard deviation 465.6. So I'm happy with that. I'm going to power these down for now, let it stay up and running on Lady Heather. It's I've got a good global heat map. I can move the antenna, probably get some more on the southern side of the heat map, but nice upgrade to the lab. Thanks for stopping by the lab and checking out the GPS disciplined oscillator and the upgrade to the frequency counter. Just adding more capabilities in the lab so we can do some better repairs in the future. There is more to come. If you guys have any questions, leave them in the comments below. I do read all the comments. Any questions, criticism is always welcome because all it does is help us improve. So let us know how we're doing, and we will see you in the next video.